you're going to use, as far as the electronics goes, 3 electronic components. So 3 individual parts. The first one is a push switch. And we can see there's this symbol that's used, which we'll talk about a little bit later, for a push switch. And graphically, that's what it actually looks like. And that's cut out of the top piece of plastic. The next component is the battery. And it looks like that. And that's the circuit diagram symbol for a battery. And then the final component to give the light is a light emitting diode, or LED. And that's what it looks like graphically. And there's the circuit diagram symbol. So we need to understand a little bit about electronics before we start. Now, if your TV was purchased, for example, in Japan and it broke, you wouldn't send it back to Japan to be repaired. It would be repaired locally. So the technical information that comes with that brand or that make at the local repair shop would be provided in the form of a series of circuit diagram symbols, and 3 of these are shown: LED, battery, and the push to make switch. And those would be joined together a certain way to create what we call a circuit diagram. So you can imagine for a TV set or something like that, the circuit diagram would be extremely big, and it may have hundreds or even low thousands of individual symbols on it. And these symbols are internationally agreed, and it's a whole new language of electronics. So, for example, if you were a German electronics engineer, this symbol here, or circuit diagram symbol, will always mean light emitting diodes. You do not need to speak English. It means the same, whether you're in Japan, Korea, Australia or Germany, that symbol remains the same. So we need to remember that for a circuit to work and be successful, all circuit diagram symbols must be connected the right way round, they must be in the right place, and the circuit itself must have no breaks with it inside it, or in the circuit itself. Now, many of you on many occasions will have got batteries, put them in a toy or something like that, the wrong way round, and it won't work. And you take the battery out, put it in the right way round, and there we go. So in this case, the battery looks like this, and it has a positive on one side, nothing on the other side. And the other side is a negative, the underside is a negative, and that's shown here with that negative, the small horizontal line. The LED's got to be connected in the right way round, and the cathode, which I'll talk about in a minute, or negative, is shown there. So these must be connected the right way round. If you connect it in and you put the negative leg there, the circuit may well not work. So the push to make switch, yours will be cut out in your piece of acrylic. Okay, and what that means is that it's basically a mechanical switch that's flicked or pressed into place. So this is pushed down and it connects the circuit. And if everything's connected correctly, the current can run around the circuit, and the LED, the light emitting diode, will emit or give light off. So it only works when it's pressed down. It needs to be pressed down with the thumb. So it's a safe method of turning a circuit on and off. And it'll be made up of part of the torch top. Okay, and it looks very similar to what we've got here. You'll have seen this earlier in your presentation. So the battery, this provides the energy. It has a positive and a negative. We know that there's different sizes of batteries. Some have got more volts or more energy in them than others. They've got to be connected the right way round, which we've said. And the great thing about batteries is they are very portable. The downside of batteries is that they're difficult to recycle. A good point is that they can be, we can get rechargeable ones. Batteries, whether they're rechargeable ones or ones we dispose of, are very expensive. And when we want to get rid of them, they are full of toxins as well, so they're not very good for the environment. Now, if we move on to the LED, an LED, a light emitting diode, a diode only lets current go through it one way. That's why it's got to be connected the right way round. And this type emits, it gives off light. So press the switch, the LED will give off light, it'll emit light, okay? These are very common if you look at your standby switch on your TV or something of that nature as an indicator when something's on or off or on standby. They're available in different shapes. So when we look down on the top, most of them are round, but we can get them in squares and also triangular as well. The most common size is 5mm diameter, but you can get 3 going down to 1.2 and actually going up to about 12mm as well. The colours tend to be red, although you can get them in blue, green, amber and orange as well. But like I said, red is the most common. If you put too much energy through an LED, it's going to blow, okay? And in our case, we don't need to put a resistor in, which will reduce the amount of current that's going into it. We don't need to bother with that, but in many cases, too much will just make it go slightly black instead of red, and that's it, it's no good. You'll note that it's got a positive leg and a negative leg to show you which way round in the circuit it needs to be. So there's the negative leg, there's the negative, it needs to go that way round. Also, we refer to the positive leg as the anode and the negative leg as the cathode. Okay, so the short leg is the cathode and it's the negative. The long leg is the anode and it's the positive. Now, should these legs get cut off with a pair of pliers to the same length, there is a little shoulder on the neck, a little flat on the neck or the shoulder of the LED there, which will actually show us that's the negative or the cathode. Okay, so just to recap, a circuit diagram is a diagram or drawing of all the parts in the correct place. Okay, and the correct way round with no breaks in the circuit. You've got the LED, which will indicate when something is on or off, or it will emit the light for our torch. The battery provides us with the energy to power that. And then the switch is a push to make switch. And a switch is a good mechanical, safe way to turn the circuit on and off. Thank you very much.